Good morning, teachers. An article by Phillips in 2019 suggests that Singaporeans on average are getting 6.3 hours of sleep on weekdays. To test this, we will be using an online survey conducted by Omnibus of sample size 1051 to test the claim. The null hypothesis represents the assumption that there is no significant difference in the population from what we already know. In this case, the null hypothesis is that the mean sleep time for Singaporeans is 6.3 hours. We start with the assumption that the claim is true because we need to test whether any observed difference in sample data is simply due to random chance or if the difference is large enough to suggest a real difference. The null hypothesis is the default assumption that we try to disprove with the sample data. The alternate hypothesis represents what we want to test or prove. In this case, it suggests that the true average sleep time is not equal to 6.3 hours. The alternate hypothesis reflects the idea that the sample data might show a significant deviation from 6.3 hours, meaning that the claim could be false. It could either be greater than or less than 6.3 hours, so we will be conducting a two-tailed test. To calculate the sample mean of group data, I first found the midpoints of each group and divided the sum of the products of frequency and the sleep that they had of each group by the total number of surveyed Singaporeans. To find the standard deviation, I use the formula standard deviation equals to square root of sigma f times x minus x bar squared divided by n minus 1. This gives us a standard deviation of 1.15 hours given that the calculated mean is 6.288. Sample mean is the average value of the sample, and sample standard deviation measures the spread or variability of the sample data. The test statistic measures how far the sample mean is from the hypothesized mean in units of standard error. For the test statistic, I will be using a t-test to find the t-value of our sample because the population standard deviation is unknown and I must estimate it using the sample standard deviation S. The t-value is calculated with the difference in the sample mean and hypothesis mean divided by the standard error of mean, which is the standard deviation divided by square root of sample size. P-value is calculated using this Excel formula. The p-value of 0.75 suggests that there is about a 75% chance of observing the sample data or something more extreme under the assumption that the null hypothesis is true. The margin of error is a measure of the uncertainty or precision in an estimate commonly used in surveys, polls, and statistical studies. It is the range within which the true population value is likely to fall. The margin of error is calculated by multiplying the t-value associated with a 95% confidence, which is roughly 1.96, with the square root of product of p and 1 minus p divided by sample size n. This is also known as standard error of proportion. The confidence interval can be interpreted as an estimate of where the population mean is likely to be given the sample data. And confidence level is the chance of which the true mean lies within the confidence interval. To find the upper and lower bound of the confidence interval, we add and subtract the margin of error from the sample mean respectively. In my case, the confidence interval has a lower bound of 6.277 and an upper bound of 6.3. This means that I am 95% confident that the actual mean hours of Singaporean sleep is somewhere between 6.277 and 6.3. In other words, the data from the sample is consistent and agrees with the article claim that Singaporeans on average get approximately 6.3 hours of sleep. Hence, we accept the null hypothesis. Thank you.